Good morning, students. Today we will start our fourth unit of LOC. This unit is related to computer systems, their machine instructions, instruction cycles, instruction formats, their modes. So first topic is machine instructions. We all know about instructions. What is an instruction? Instruction is basically a command which is given to a computer to perform particular operation on that given data. Means instruction क्या है कि जो भी डेटा हमारे पास है उस पे जो भी टास्क हमें परफॉर्म करनी है उस डेटा पे जो भी ऑपरेशन परफॉर्म करना है उसके रिलेटेड हमें कमांड्स जो हम यूज़ करते हैं दैट इज़ कॉल्ड इंस्ट्रक्शंस. और हर कंप्यूटर्स के लिए डिफरेंट नंबर ऑफ इंस्ट्रक्शंस होती हैं. डिफरेंट इंस्ट्रक्शंस आर यूज्ड फॉर डिफरेंट पर्पसेस. So number of instructions available and their efficiency to solve different problems in different ways. That all depends on the machine which we are using. And instructions that we are using must be compatible with our system, that they can solve our problems. There are different types of instructions, different operations to be performed like arithmetic, logical, some related to memory, input-output devices, or you can say registers also. So this is a basic block diagram of our digital computer. Computer is a device, electronic device, which is used to perform different operations on the data given to it and gives the output or result. So this is a basic block diagram of digital computer. In this there are different terms which we are using now. First is PC, that is program counter. It is 12-bit program counter. It is used to store the address of next instruction that is to be executed. Memory address register MAR is also of 12 bits. This is used to store the address of memory. CIR, it is used to hold or store a current opcode which we are using present. Control logic is used to control the different operations. Here F is fetch flip-flop and S is start flip-flop. Is of 1 bit. Start and stop flip-flop. Sequence register. Sequence register, it is used to provide signals in sequence. It is used to provide timing signals. Master clock generator. Master clock generator is used, you can say it is used to generate clock pulses. Clock pulses through which we can synchronize our system. Okay, next is input register. Input register is of 9 bit. That means it is used to store 9-bit input. It gets data from input devices. Output register, it is also of 9 bits. It is used to provide output data to the output devices. Next is accumulator. It is of 16 bit and it is main register which is used to process every instruction or every task. Okay, this is E is extension flip-flop, means accumulator extension. It is used for extension of accumulator. Means suppose if we are adding two values and there is a carry output from the result of that values, so we have to store that carry also. So this E is used for extension of accumulator. मीन्स अगर एक्यूमुलेटर 16 बिट का है, हम दो वैल्यूज़ को ऐड कर रहे हैं और वो 16 बिट से ज़्यादा आ रही है, कैरी आ रहा है उसमें 17th बिट, तो उसको स्टोर करने के लिए हम ये ई यूज़ कर रहे हैं. MBR, it is memory buffer register, or you can say MDR, memory data register. It is used to store data, store the contents of memory. This is total memory unit. Total memory unit is of 4096 words, and each word contains 16 bits. Okay, so this is the overall block diagram of digital computer which we are using. And in this computer we are using instructions. These instructions are of 16 bits. 16 bits are divided as 12 bits and 4 bits. 12 bits are used for address and 4 bits are used for opcode. So lower 12 bits, that is 0 to 11, this is used for address, representing addresses, and for 12 to 15, 4 bits are used for opcode. So, and types of these instructions which computer uses. Computer has basically 3 types of instructions. First is memory reference instruction, second is register reference instructions, and third one is input output reference instructions. So first is memory reference instructions. In this, computer uses memory addresses for these instructions, for the process of any task. As we have discussed, instruction is of 16 bit. So same instruction format is used. It is of 16 bit, 0 to 15. And 0 to 11, 12 bits for addresses. These addresses are related from memory. These are known as memory addresses. And the remaining 4 bits are for opcode, out of which 12, 13, 14, 3 bits represents opcode, which has any values 0, 0, 0 to 1, 1, 0. 1, 1, 1 is not used. This is not used for memory reference. Okay, and the last bit, 15th, is I. This is mode bit. It is used to represent the mode which is used here. If I is 0, that means it uses direct address. And if I is 1, it means it uses indirect address. That means their opcode is of 3 bits and the 4th bit is this mode bit. And the value of opcode is 0, 0, 0 to 1, 1, 0. That means 0 to 6. Okay, and if we are adding this I, 0 or 1 in front of these bits, it becomes 4 bits. It becomes 4 bits. That means if we are placing 0 in front of 0, 0, 0 to 1, 1, 0, then it becomes 0 to 6. And if we are using 1 in front of these bits, it becomes 8 to E. That means 1000 is 8, 1110 is E, means 8 to 14. It depends upon this mode bit. What is the value of our opcode? 3 bits, we know that for 3 bits we are having 8 values, 0 to 7. But in this we are using only 0 to 6, 7 values. 7th value is not used. Okay, so 3 bit opcode है, तो इसके लिए वैल्यूज़ होंगी 0, 0, 0 से लेके 1, 1, 1 तक. लेकिन हमें सिर्फ 1, 1, 0 तक यूज़ करना है, 1, 1, 1 यूज़ नहीं करना. और जो ये 4th बिट है, ये आई है आपकी मोड बिट. ये सिलेक्ट करेगा कि हम डायरेक्ट एड्रेसिंग यूज़ कर रहे हैं या इनडायरेक्ट. अगर ये 0 है तो इसके आगे अगर हम 0 लगाते हैं, दैट मीन्स ये 0 to 6 बनेगा, तो ये आपका डायरेक्ट एड्रेस है. इनडायरेक्ट के लिए हम ये 1 बिट यूज़ करेंगे इसके आगे, तो ये इनडायरेक्ट एड्रेस है 8 to E. Okay, and addresses is from memory. Next is register reference instructions. These 3 instructions are similar to each other. There is only little bit difference. So second is register reference instruction. In this same 16-bit instruction, this 0 to 11, that address part is for register operation. In memory reference, this is for addresses, memory addresses. But in this, these 12 bits are used as register operation. The next is opcode 3-bit, and its value is fixed for register operation. It is 111, and the mode bit is always 0 for register operation. So total opcode is 0111, 4-bit. That means it is 7. 0 to 6 are used in memory reference, and 7th is used in register reference. Remaining process is similar. And its third type of instruction is IO reference instruction. IO means input-output reference instructions. As in case of memory reference instructions, address part is related to memory. For register reference instructions, address part is related to register operation. And in case of input-output, this 12-bit address part is related for IO operations, means input-output operations. Then this 3-bit is for opcode. It is also fixed 111. And the mode bit is always 1 for IO reference instructions. In case of register reference, it is 0. So opcode is 0111. But in IO, mode bit is 1. So opcode is 1111, that is F. For memory reference, it is 0 to 6 and 8 to E. And for register reference, it is 7, 0 111. And for input-output reference, it is 1111, that is F. Okay, these are the basic types of instructions used by computer. And our next topic is instruction cycle. Instruction cycle means that we have to execute instructions in the computer. Instructions stored in the computer. So how we will execute it? Mainly we know that instruction consists of two parts, opcode and operand. Opcode tells the operation code, means which operation is to be performed. Either we have to perform add operation, multiply, compare, subtract, whatever operation is to be performed, that represents by opcode. And second part is operand. Operand means you can say data or addresses on which operation is to be performed. Data or memory addresses on which operation is to be performed. Means these 12 bits are for address. These are for operands, on which this opcode tells which operation is to be performed. So basically our instruction cycle consists of two parts, fetch cycle and execute cycle. Fetch means to read the instruction from the memory, and execute means to execute that instruction which you have read from memory. So this is a basic diagram flowchart for instruction cycle. To start the process, then we have to fetch the instructions from the memory, means read the instruction from the memory, and then we have to execute the instruction. After executing first instruction, this process repeats from second instruction. Repeats for second instruction means we have to fetch the second instruction and then execute. This process repeats until all the instructions are executed. Then we have to stop. This is the basic, you can say, basic process of instructions to be executed. Now, instruction cycle consists of fetch cycle and execute cycle. Now, this is the instruction fetch cycle procedure, that how we can fetch instruction from the memory. So, this is the process which is used to represent fetch operation. This is main memory. This is MDR, memory data register. IR instruction register, instruction decoder. This is MAR, memory address register. This is program counter, and +1 is represented to use to increment this program counter. So in this process, when a program is to be executed, the program counter which is used to store the address of next instruction to be executed. So this address is transferred to MAR, and from main memory that instruction is to be fetched and it is read and store it in this MDR register. MDR is memory data register, means data from the memory is stored in this. And this instruction is basically consists of two parts, that is opcode and operand. So from MDR, the opcode part is placed in IR, that is instruction register. Opcode is loaded into IR, instruction register, that which operation is to be performed. So we have to decode this value. So instruction decoder is used to decode this opcode, so that we can understand that what operation is to be performed. And that operand means the data on which operation is to be performed is placed in MAR. And then operation is performed. And then after this, the program counter is incremented for next instruction to be fetched. And after fetching this instruction, the next step is to execute this instruction. And how this instruction will execute? After fetching and decoding operation, instruction cycle begins to transfer this data from MAR to main memory. That means that address into main memory, and from this data is transferred to MDR, that is memory data register. And from this data register, this data is loaded into ALU. ALU is arithmetic and logical unit, which is used to perform arithmetic as well as logical operations. Okay, opcode tells the operation to be performed, and operand tells the data, gives the data on which that operation is to be performed. So in this execution cycle, the transfer of operand part of IR to MAR, and the data is fetched into ALU from this memory, and then operation code, which is decoded by the instruction decoder in the fetch cycle, is to be used for the arithmetic and logical operations in this ALU. This is execution cycle. So the instruction cycle is consisting of two parts: fetch cycle, execute cycle. In fetch cycle, the instruction from the memory is placed in MDR, and then it is divided into two parts: opcode, which is placed in loaded in IR instruction register, and operand is used in MAR, that is memory address register. So opcode is decoded so that we can know the operation, and then in execution cycle, the opcode which is decoded is used on the operand which is stored in MAR, and then with the help of ALU, arithmetic and logical unit, the operation is to be performed. This is our instruction cycle.